Hey everybody, this is the first example I was going to do. Just these are kind of like reminders of how to do some of these volumes of revolution. I was going to do one, uh, kind of a standard one. That's the first one here. Next video, I'll do one. I'll do one that's a little more tricky, and then I'll do a third one that's a little more complicated. I wanted to give you guys a few extra examples in case you forgot how to do this. You may remember we said in general for a volume of revolution, it's something like this. This is kind of our general conceptual formula. If you look at the picture in the little set of notes I sent you guys, it says this first one. There's a picture which I think helps you to understand what this thing is going to look like, kind of like a cone with the top chopped off of it. But either way, the idea is that there's like a bunch of little circles whose radii are here. The radius, the bottom of the radius is here, and the top of the radius is here. And so if I imagine like a representative radius here, the bottom curve is y equals 0, and the top curve is y equals root x. And I'm spinning it around y equals 0. The problem says use the disk method to find the volume of a solid by rotating the region between the graph of root x and the x-axis around the x-axis. And this is this concept of disks versus washers, which is that it says the region between root x, which is this curve, and the x-axis around the x-axis. So one of the edges of my region here is the axis of rotation. Therefore, there's no inner radius. Or you can think of the inner radius as being 0. Either way. But this should be when it's disks, it's a little more straightforward because there's no little r squared. You just think of this volume as pi times the integral from 1 to 4. Those limits I knew because they just gave them to me. Of the top curve squared. So remember, this is like big R right here. And it's like you always do top minus bottom. So it's root x minus 0 squared. And then little r is like y equals, it's like 0 minus 0. There's no little r. It's like the axis of rotation and the bottom of the curve of the region are the same. So there's no inside radius. There's no hole in this thing. So I don't have to worry about little r here. So it's just that, and it's just pi. This is if I square root x, I get x dx. So that's pi times x squared over 2, running from 4 to 1, which is 4 squared is 16 over 2 is 8. And then 1 squared is 1 over 2. That's 15 pi over 2, I think. So this is how you do, this is like kind of your standard disk, the axis of the thing that you're spinning it around and the edge of the region are the same. So you can see little r didn't exist in here, a equals 0. Top minus bottom to find big R, root x minus 0. Top minus bottom to find little r is 0 minus 0, and then we're done. So keep an eye out for the next video.